Hi, this is Mrs. Cahill, and we're starting on number 31 for our FSA review. Which function shows a constant positive rate of change followed by a zero rate of change? Notice on all of these we're talking about speed versus time elapsed. So I want a positive rate of change that should look uphill, and then a zero rate of change. That's choice C. There's my positive and there's my zero. Remember Mr. Slope Guy, our positive slope heads uphill and our zero slope is zero fun and it looks flat. Okay, for number 32, which function shows a positive constant rate of change that increases to a new constant rate of change? And I think they mean positive. And well, here's what, increases to a new constant rate of change. So anything that's curved would not be a constant rate of change. So cross off all the curves because curves aren't constant. If they want a constant rate of change, they want linear. So now I'm left with between these two here. So if I have got a constant rate of change and then I want it to increase to a new constant rate of change, I want this guy. This guy doesn't increase, he decreases. All right, number 33. What is the slope of AB written as a fraction? So AB, that's this line right here. And I could get the slope, but do you notice? I'm not landing on crosshairs right there, so I'm not comfortable. I hope you realize because of slope triangles that AB is also the same as that line right there. So I think I'm going to go find the slope of from A to D. It'll be the same slope. When I rise 3, I'm running forward 6. So my slope is 3 over 6, which is 1/2. 34. Two lines are graphed and pass through the given points. What is the value where they cross? There's a neato algebraic way you could use to solve this. However, on the FSA, they give you graph paper. So let's go ahead and graph those points. You'll want to please, on graph paper, plot the points they've given us. So we've got the point 1, 3 and the point 5, 7. And let's go ahead and graph that line. That should be good. And then we're going to plot 2, 6 and 5, 3. And we will graph that line. So what they're asking for is the point where they cross. I see it. There it is. It is at 3, 5. Easy peasy. Number 35, select all the linear functions. Normally we think of y equals mx plus b, but I don't always need to have all of those parts. Believe it or not, that is really y equals 1x plus 0. And so yes, that works out. There's a problem when we get to b. See that exponent? I don't want any exponents. On this next one, if I were really to divide, I would get y equals 2x minus 3. And that's the same thing. It's in slope-intercept form. On this one, I could get that into slope-intercept form. I could subtract 2x to both sides. I notice I have my x and my y. It's in standard form. It's still going to be linear. Also, choice E. There's a problem with F, though. It almost looks linear until you notice that exponent, and that means it's a no. So did you notice? In this case, everything that didn't work had an exponent, and that was why it didn't work out. All right, 36. Given triangle DEF and that we've got DE squared plus EF squared equals FD squared, what is true? And look at the choices. The choice is one of those is going to be our right angle. How do we know which one? Well, I am hoping you recognize that. Doesn't that look kind of like A squared plus B squared equals C squared? So why don't we label our triangle with the sides DE and EF and FD and see where the right angle is going to be? And big hint, let's go label this guy. Wouldn't he have to be our hypotenuse? So that would mean if it's the hypotenuse, I can put F here and D here. I could also move them. I could flip them around. It won't change anything. But the big deal is that is my side E. So notice we have DE squared plus EF squared. E is my right angle. It took a picture. Number 37, find X. I hope you remember to find the angles inside of a triangle. We need to remember the triangle sum theorem, which states that all three angles add up to 180 degrees. Well, we've got two of them. We could plug those in for Y and Z. And we could add 54 and 62 together, get 116, and then to get X alone, subtract 116 to both sides, and we find that our missing angle is 64 degrees. And you can check it. Those three angles add up to 180. On number 38, now we're not talking about angles. We're back to talking about sides of a right triangle. So again, anytime you're thinking of sides of a right triangle, you're thinking A squared plus B squared equals C squared. Be careful. What's the 26? I hope you recognize that the 26 is the hypotenuse and has to go in for C. So now you can square those amounts with a calculator or by hand and plug them in. To get X squared alone, I will subtract 256 to both sides. Combine like terms. We get that X squared is 420. We're not done. We want X alone, so we'll square root both sides. And we're supposed to round to the nearest tenth. We get, 20.493. And if we're rounding to the nearest tenth, we get 20.5. Double check. Were there any units? There were not. So 20.5. Use logic. That number isn't too big. It's a good thing. It's a good answer. Number 39. What transformation creates the shaded region? Clearly it's smaller, and I can tell by the way they've worded it, they want just one, and that would be a dilation. It's just smaller, similar in shape. Number 40. Lines A and B are parallel, and we're supposed to find X. So parallel, I'm going to indicate right here that they are parallel, and they want us to find angle X. And wow, there's so much going on in this picture. Sometimes it's a good idea to take away parts you don't need. For instance, I see this angle X and I see the lines that it's formed with. I'd like to cover up the lines that don't create angle X. Do you realize if I cover up this line right here, I'm not covering up anything to do with X. And while I'm at it, I'm going to cover up that 60. It's just bothering me. So now I hope you see what we really have is something just a little easier to look at. It's basically the same picture. I've got my two parallel lines cut by this transversal, and I want to find angle X. All right, I can't find X right away, but you know what I can find is this angle right here. If I've got 130 here, and if together we're making a line, don't I need 50 degrees to fill that in? Right? Okay, now here's the other thing I need you to notice. Angle X and the one where the 50 is are corresponding angles, and corresponding angles are congruent. So the measure of angle X is 50 degrees. And it turns out that they had given us more information than we really needed to find out that x was 50. If you had to guess and didn't know the work to do, I really hope you would not have put 130, because clearly that angle is little and acute. All right, number 41 is just like number 38. I'd like you to look back at 38 before you watch me do this one and try it on your own. Okay, I hope you try it on your own. Do you realize we have a right angle here? So of course we're talking about Pythagorean theorem, a squared plus b squared equals c squared. And the 11 will be our hypotenuse because it's opposite the right angle. So I've got to plug in the 11 for c. And what we don't know is x. So we've got x squared plus 4 squared equals 11 squared. Let's do our squaring. You should have those numbers memorized. And now to get x squared alone, we'll subtract 16 to both sides. And we get x squared equals 105. Now we'll square root both sides. And x is 10.2469, but we're going to round to the nearest tenth, and we will call it 10.2 meters. And that is how high up the building the ladder is. 42. Which function is nonlinear? So basically, I want to have a non-consistent slope. Let's go get slope. When I look at my y's on the first one, I'm going up 1, plus 1, plus 1. When I look at my x's, I'm going up 3, 3, and 3 again. So this one is linear. The next one. Is that linear? Well, we're going down by 4. Down 4, down 4, and we're going up by 1. So this one's linear. By the way, the slope on this one is -4/1. The slope on the last one is 1/3. But because we have that constant slope, we know we are linear. So far, nothing is nonlinear. How about the next one? Up 1, up 1, up 1, down 1. And once again, we're getting a slope. M is equal to -1/1. It was actually equal originally to +1 over -1, but I fixed it, right? And so that's linear because we're getting a constant slope. Let's see about the last one. Up 3, up 3, up 3. And for the x's, we're going up 1 every time. So once again, we have a constant slope. So guess what? Which function is nonlinear? None of them. This was a trick question. I don't think I meant to write it this way. I meant to make one be nonlinear, and unless I've made a mistake somewhere, let me know. This one appears to be, none of them are nonlinear. They are all linear. Number 43, how long is the diagonal? So they want to know how long it is from here to here. Well, recognize that if this is 26, and assuming we have a rectangle, then that's 26. And oh yeah, look, a right triangle. We are talking a squared plus b squared equals c squared. And this time, the unknown amount is our hypotenuse, the c. Makes the math a teeny bit easier. Plug your numbers in properly. 18 squared and 26 squared respectively. 324 and 676. Add them up. Ooh, a nice even 1,000. Square root both sides. It doesn't come out great though, does it? Nah. It becomes 31.62 approximately. Did they ask us to round? They didn't. That's probably a mistake in the question. They would normally ask us to round some amount. But that diagonal is about 31.62. And that makes sense too. I needed it to be longer than 26. 44. Andy and Amy each babysit. Andy's total charges are represented by the function y equals 15x plus 10. And Amy's charges are $10 per hour plus a $20 fee. select all the true statements. And of course, you should always pause and reread this and try it on your own. I like to kind of indicate what they've given us. Here's Andy's amount, and Amy, I'll do her in red. She's got $10 per hour plus a $20 fee. So Amy is my $10 per hour, that's 10x, and that $20 fee, that's only happening one time. So there's Amy's equation, and above we have Andy's equation. Now let's go see what's true. Amy charges more per hour. So her rate is 10, his rate is 15. No, Andy charges more per hour. Amy has a greater initial fee. Well, her initial fee is 20, his is 10, so yes, 20 is bigger than 10. Andy has the greater initial fee. No, we just said Amy does. All right, part E. The total charge for $2 is the same for each. That means I've got to plug in 2 for X into each child. So let's go do Amy and Andy. Andy, when we plug in 2, plug that into his equation. 15 times 2 is 30, plus 10 is 40. What does Amy charge? Well, we take her equation and we plug in 2 for X. 10 times 2 is 20, plus 20 is 40. So they charge the same. Oh, and that's what it said. They do. They charge the same for 2 hours. Now they want us to find out for 3 hours who charges more, Amy or Andy. So let's go do the same exact work. Pause and do that work on your own. You don't need me to plug in 3. When we plug in for Andy, his 3, 15 times 3 is 45, plus 10 is 55. And for Amy, when we plug in 3, 10 times 3 is 30, plus 20 is 50. So it turns out Andy charges more, not Amy. And we've got our 3 correct answers. All right, number 45. What is true about the number of meals packed per hour? Select all that apply. So look over at your graph. We've got our time in hours, and we've got our total number of meals packed. And they want to know what's true about the number of meals packed per hour. I hope you recognize that that is slope. And we can get slope with rise over run. So pick any place that we hit crosshairs. I think I'm going to choose crosshairs where I also have numbers. It makes things easier. So if I rise to 250, I run 2. So my slope is 250 over 2, which divides to be 125. Let's add words to that. It's 125 meals per hour. Now, let's go see which answer looks correct. 250 meals are packed per hour? No. 125 meals are packed per hour. Yes, that's what we calculated. Let's keep going. We have to select all that apply. 100 meals are packed per hour. No, we said 125. Choice D. As time goes on, more meals are packed. As time gets more and more hours, more meals are packed. Yeah, that's heading uphill. We have a positive slope. So choice D is good. E, as time goes on, fewer meals are packed. No, that's the opposite. And choice F, 1,250 meals are packed in 10 hours. Well, we could read it right from the graph. At 10 hours, oh look, we do indeed hit 1,250. So that's correct. 46, they want us to find the value of X. And we have to do something very similar in 47. It's just turned around. And we have different numbers. I want you to remember this, that when I have a triangle and an exterior angle, the deal is the sum of the 2 remote interior angles is equal to the exterior angle. So look who we didn't need. We didn't need this guy right here. So I'm going to pull him out of the picture and look again. A plus B equals D. So let's do the math over here. See the 55 and the 45? My picture's turned around, but those are like A and B. So my equation on this one will be, oh, and I wrote the wrong number. I apologize. 55 plus 45. Hopefully I added them up right, though. We'll see. 55 plus 45 is 100. And so in this case, X is 100 degrees. All right, number 47. This one's a little bit different. It's still the same math. The two remote interior angles add up and equal the exterior angle. But this time our variable isn't by itself. 40 plus x equals 100. To get x alone, we would subtract 40 to both sides. So x is 60. The measure of angle x is 60 degrees. The math is easy. You just have to remember the rule. 48, select all the true statements. So this is just like the other two we did. Didn't we say that the way this works, A plus B equals C? And that's the guy I have. And couldn't I say B plus A? That's the same thing. Those two are exactly the same. So here's what we said. We said A plus B equals C. Couldn't I get A alone if I wanted, or B alone if I wanted? Let's go try. What did I do? I subtracted A to both sides. I'm allowed to. What will it look like when I do? I'll have B equals C minus A. Isn't there something that looks kind of like that? B equals C minus A. So that one really is the same thing. I just manipulated the equation, but it's still the same. I hope you recognize that. So that's the last question in our last review for the FSA. I hope you were able to do most of these on your own. You should go back, re-watch. It's such a great preparation for you for the FSA, and your goal should be to pass and improve upon what you did last year and ace this thing and go on to high school and be successful. Thank you so much.